So today we will see about B trees. So before going on to B trees, let us discuss what is index. What is meant by index?
The address.
We have index page in all the notebooks. So what is an index?
Define next page
ಇಲ್ಲ.
அதாவது அடுத்து அந்த இண்டெக்ஸ் வேல்யூஸ் தான் எங்க இருக்குன்னு அதோட ஒரு
Index
பாயிண்டர்
page.
மாதிரி
For example, what do we have in index? We will have serial number, topic,
Page number.
page number.
Page number. Yeah.
So for each topic, we will have a specific page number. So for example, topic A இருக்கு அப்படின்னா, we will have page number 1. For topic B, we will have page number 2. So in the same page number, we will not have more than one topic indexed here. Correct? More than one topics will not be reference to the same page number. So what is the use of having page number here? What if this page number is not listed and only we have the topic here? Is there any use? What I'm asking is we do not have any page number here. If I have only the topic listed in this index page, is there any use? No. Why?
Yes.
Customers.
I cannot redirect to that page. I cannot find where this particular topic is present. So this particular page number acts as a reference to this topic. So it is for easy retrieval. So same is applied in DBMS also. So multiple records, multiple tables will be stored in the database. So for indexing each table or indexing each tuples, we will use indices. So there are many types of indexes. Of all those types, we have one specific type called as ordered indexes. Ordered index. So in the ordered index, we have two types. One is B tree, other one is B plus tree. So this B tree comes after the name binary search tree. So what is binary search tree?
Left side la
There are two main properties of binary search tree. What are they? First property is that it should be a binary tree, which means it should have only two children. Second is all the values in the left subtree should be lesser than the root, and all the values in the right subtree should be greater than the root. So left subtree it should be lesser than the root, right subtree it should be greater than the root. So these two properties of binary search tree is applicable to B tree as well. But one difference between binary search tree and B tree is that in case of binary search tree, we store all the values in nodes. In case of tree, by default, all the key values will be stored inside a node. So in binary search tree, if we take one node, inside one node, we will have only one value. But in case of B tree, if we take a node, each node can have more than one values. More than one values. So each node is not restricted to only one key value, but we can store more than one key value inside a particular node. So the number of key values that can be stored inside a particular node is determined with the help of the number of key values that can be stored inside a node is determined with the help of order. So the order of a tree determines how many key values we can store inside a node. For example, if order is equal to 4, how many key values can I store? 3. So if order is equal to m, I can store maximum of m minus 1 key values inside a particular node. So this one property of B tree differs from binary search tree. So what other properties do we have? First property is that given if order is equal to m, so maximum key values that I can store is m minus 1. So what is the minimum key value that I can store?
M by
It
2.
is floor of m by 2 minus 1. Clear? So what is the maximum number of children it can have? If order is equal to 3, maximum how many children does that particular node can have?
3.
3. If we order 3 means we can have maximum of 2 keys. So this is one children, this is another. So this indicates reference to the, for example, let us take these values 2 and 4. So this point act as a pointer or reference to the 2, to the left subtree of 2. Similarly, this one acts as a pointer or reference to the right subtree of 2 and left subtree of 4. So this acts as the pointer or reference to right subtree of 4. So maximum number of children that can have in B tree of order m is m. If it is of order m, maximum number of children is also m. Minimum number of children? Minimum number of children is m by 2 for all internal nodes, but for root node it can have Any root node, any B tree of any order can have minimum one child in root node. So this property is not applicable to root node. It is only applicable to internal nodes. So what if instead of order degree is given?
You have to convert degree into order.
So you will convert the degree into order. So what is the formula to convert degree into order? 2t. So t represents order. So 2t is 2t order. T is your degree. So 2t is order. So of order of degree t அப்படினா order m equal to 2t. Maximum key is only 2t minus 1. Clear? Understood? So yeah. So how many levels can it have? 3 levels, m levels. So level 0, maximum it can have m levels of order m. So 0, if it is of order 3, maximum it can have up to level 3. So level 0, level 1, level 2 and level 3. Understood? So now let us insert values from 1 to 10 of order 3. So one more property is that inside the node, the values has to be arranged in,
Ascending
so the
order.
key values has to be arranged in ascending order. So first, if it is of order 3, each node will have maximum of 2 children. So the values are 1, 2, 5, 6, 7, 8, 9, 10. So initially I will insert 1, then I will insert 2. So when I want to insert the value 3, can I insert? No, because already the node is full. So I have to split the node. So how do I split? I have to arrange these values in ascending order. So I have to find the middle value. What is the middle value here? 2. So now this middle value will move one level up. So it will move one level up. So to the left of 2 we have 1, to the right of 2 we have 3. So 2, 1. To the left of 2 we have 1. To the right of 2 we have
3.
So every time you draw a node, you should not draw like this. Every time you not draw a node, the node should be represented with the number of keys that it can hold. So though it is not having the maximum number of keys, you have to represent the node with the number of keys it can hold. So what is the next value? 4. So first that 4 will be, and one more thing is all the values that we are going to insert will be inserted only in the leaf node. It will not be inserted anywhere in the internal nodes.
Okay.
So insertion always happens in the leaf node. So now if I want to insert 4, 4 is greater than 2, it is greater than 3. So this is the leaf node I can insert here. So can you continue?
Yes. So now we have 3 and 4. So next we have to insert the 5. Before that, this node is full. So we have to split into 2. So like we have to, just like ma'am said, we have to find the middle value like 3, 4 and 5. So here the middle value is 4, right? So we have to split the node into 2. So it becomes yeah. 4
So when
will
you
replace
split, how do we split? Right here like this.
like so 4. Its left side is 3 and right side is 5.
So this 4 will go one level up.
Yeah.
4, if it was one level up, here
Here
we
is
have empty
node,
spot,
so
so I
we
can
have to-
insert 4 here.
Yeah. So further we can achieve like we have to write 2 and 4 and then 1 as well as the one is
So when you are drawing the branch, you should not draw like this.
oh okay.
Only this represents the pointer. அப்ப அங்க இருந்தா you should draw the branch.
Okay. So the 4 have 2 nodes in the leaf nodes like this one. This one.
No. 2
3
right,
என்னது 3 is
left
greater
side.
than 2, but it is less than
Less than
4. அப்ப 4 ஓட left pointer you have to draw 3.
3.
Oh, this one is 4 left pointer. Okay.
Two
So
to the right.
this one is 3 and this one is
To the
the
right
right
pointer.
pointer. So this one is
5.
5.
5. So next we have to add the 6.
6.
As
5
well as,
after 6.
so we have to place the 5. Sorry, 6 after 5.
4 is greater than 5.
Yes, we have to place this 6 here, and then we have to insert the 7 as well as we also see. Sorry, we have to repeat the same process. This 4. Wait a minute. So we know that here the values are full, like 5, 6 are full. So we have to add the 7. So we know that 6 is the middle value.
Middle value.
Yeah, middle value.
6 moves up here.
But the
6
node is
moves up here.
Ah.
And check whether 2, 4, 6 middle
Then
value.
it's this.
Then
let's-
4 will be coming in now. And the next values which is right and to left will be going down.
Oh, can you show me? Okay.
First we have to insert 7
Yeah.
and here 6 is the middle value. So 6 will be going here. Then 2, 4 and 6 because there is no space here.
Yeah.
And in here we have 4 as a middle value. So we will be drawing as 4 here.
Okay.
And next we have a 2 and we will be drawing 2 here. And to the 2 and to the left we have 1. So we will be drawing here as 1. Then to the right side we have 3. So we will be here, we will be writing
இங்க
3.
வந்து
4 on the
correct
right.
ஆ?
Then
See, if you are
4 to
drawing as
right,
right
one shot.
pointer, you have to draw here. You should not
right
insert
pointer.
here.
Okay.
So yeah, that you should not insert this note here.
4 on the
What I'm
right
telling is,
3.
this is correct. You should not insert a pointer like this.
Okay.
That is wrong.
And to the 4 we have 6. 6 and
So the every values are
Six
inserted.
soda left leg we
6 on
have.
the left
Oh,
leg
okay.
we have
5.
7.
5.
5.
Then 6 on the right leg we have 7.
7. Right.
Then next value is 8.
Eight.
8 will be going here. Then next value is 9. We will be checking with 7, 8 and 9. Middle value is 8. So 8 will be going here. So we will have 4, 2, 1, 3 and 6. And the 8 will be going here. So 8, then 5, then 7, then 9.
Okay.
Sorry. To 8 that is left side is 8, 7.
So
To right
of
side we
eight,
have 9. So 9 will be coming there. Then next value is 10. So
Yeah.
next value 10 will be added here.
And then
And you have to, so finally you have to check the number of levels is less than order n. Here we have order 3. So number of levels, level 0, level 1, level 2.
Yeah.
So
It is
number
less
of
than-
levels should be less than or equal to order n. If it is greater than, it means your answer is wrong.
Okay.